So yeah, the next video poster is from Neuton.ai.
Hello, my name is Blair Newman. I'm the CTO here at Neuton. Now here at Neuton, one of our missions is to truly make machine learning available for everyone. Now how do we accomplish this? We accomplish this because we've produced a solution that enables the non-data scientist, irrespective of your technical experience and skills, as well as empowering the data scientist. Now specifically, for the tinyML community, our solution produces extremely accurate models that are compact and ready to be integrated as soon as they are produced. I would love to share with you our bottoms-up approach to building extremely compact models. Our patented framework builds all models neuron by neuron, ensuring that we're always producing a model of the most optimal size. Watch our quick bite here on YouTube on how Neuton accomplished this. Glad you have joined us, and have a great day.
How does Neuton create incredibly compact and accurate models? First, Neuton uses a selective approach to the connected features. Let us take as an example, the model for determining cardiac arrhythmias. Amplitude of contraction of the heart muscle acts as one of the features for training the model. As you can see, Neuton only needed to make connections with half of the features. We also leverage a unique patented algorithm to adjust the coefficients within a model. Unlike most algorithms, Neuton's algorithm is not based on backward propagation of errors and the stochastic gradient descent. Furthermore, the Neuton algorithm is minimizing the likelihood of hitting local minima. This is especially important when building small models. You can see that in our example we've achieved an area under the curve value of 0.96 with only 253 coefficients. Meanwhile, achieving the same accuracy with TensorFlow requires significantly more coefficients. Neuton is even 10 times smaller than TensorFlow Lite. The Neuton platform enables models to be built automatically, neuron by neuron, starting from learning general features and moving toward identifying the most specific ones. This allows selection of a model of almost any level of precision and size, in a single iteration. The Neuton eliminates the time-consuming multidimensional manual search for network parameters including number of layers, neurons, type of activation function, batch size, dropout, learning rate, and more efficiently finds the optimal structure. The neuron by neuron growth makes it possible for cross-validation to occur progressively, which is typically not feasible with a standard approach. The combination of these characteristics also increases the generalizing capabilities of the model, which allows for creation of compact models, without compromising accuracy.
All right, that was a great video demo. We have a couple of questions from the audience. So can you share successful examples where Neuton was used to solve customer problems except the cardio application?
Yeah, so we have worked with some customers in the IoT space. So specifically a customer in the logistics side of the house where they are, as an example, they're tracking packages, as relates to temperature shock, so that their customers, when they actually receive the package, they're able to validate in real time if whether or not the package should be accepted or not. When you look at how the customer has previously been working, how most people work today, typically a lot of that data is sent back to the cloud. Then once it's sent back to the cloud, then of course, some analysis is taken. And oftentimes those results are produced hours later, where now their customer are able to see the results in real time and can determine just instantly if whether or not the package should be accepted.
All right. So is Newton framework compatible with TensorFlow and PyTorch? And how can we try Newton software?
Mhm. Yeah, so the algorithm that we're leveraging is one that we have developed in-house. So it is an alternative, let's say, to TensorFlow, TensorFlow Lite, et cetera. One of the things that we try to highlight is that our approach is that we're building all of our models neuron by neuron from the ground up, which is allowing for us to produce extremely compact models. So you don't have to go through perform any quantization, pruning, et cetera, which oftentimes will have a negative impact on the accuracy of your models. In regards to being able to take advantage of our platform, anyone can go to Neuton.ai and can sign up to access our platform completely for free. And our free version of our platform, you have the, for all intents and purposes, the full functionality as our paid version. So just go to Neuton.ai and you will be able to access our platform and realize the results.
That sounds very great. So how about the hardware requirement? Can it run on ARM series?
Yeah, I'm sorry, I should have commented on this. So on the models that we're producing, even though, of course, our algorithm that we have developed ourselves, when our customers are downloading all of the models, they come out fully open. So you'll receive the binary file, all of the necessary dictionaries in order to take advantage of our models without any tiebacks to our platform at all. And also when our customers do download our models, you still have the ability to take advantage of our explainability office. In this case, one of the key areas of our explainability office is we also include a lifecycle management tool where we will proactively identify if whether or not your model is beginning to decay, you may need to perform some training.
All right, sounds good. Thank you for your video session and the answers.
Okay,
All right.
sure. Thank you.
We especially want to give thanks to our strategic partners, which really helped us that we can make that event possible. So we have first our executive sponsors. We have ARM, which is the software and hardware foundation for tinyML. Then Edge Impulse, tinyML for all developers. Qualcomm AI Research, advancing AI research to make efficient AI ubiquitous. Sentient, end-to-end deep learning solutions for tinyML and Edge AI. And our platinum sponsors, Reality AI. They add advanced sensing to your product with Edge AI, tinyML. Then also we have Renesas, broad and scalable edge computing portfolio. Our gold sponsors, Latent AI, adaptive AI for the intelligent edge. Maxim Integrated, enabling edge intelligence. Seed Studio, the IoT hardware enabler. SensiML builds smart IoT sensor devices from data. SynSense, building sensing and inference hardware for ultra-low power embedded mobile and edge devices. And our silver sponsors, we have Aeon Devices, Deep Light, EMSA, Green Waves, Gravity Inc., HOTG, Imagibob, Mob, Geekzo, Rixon Technology, and SAP. So we really want to thank all of our strategic sponsors who will help us. And I hope you all enjoyed it and that we see you again tomorrow. Good evening, everyone.